Okay. I start already.
So, good morning, dear students. Today I am going to discuss about the energy infusion in the electronic devices. That means how the energy actually infuses and then how it gets heating. Yeah? Electronics devices heating. Heating impact. And so you know that actually we understand from the thermodynamics that the energy as a heat actually how it flows to the mass flow system with the specific capacity and the temperature change. That one we will know well. Yeah. Then we also know the electrical energy, that is the voltage, I is the current, how associated with the V is nothing but the electric potential, yeah, and I is nothing but the electric current. So actually it is V del Q by del T. Actually it is actually the energy flow. This is the electrical energy electrical energy flow. That is del E by del T. Electrical energy flow as a power, yeah, electrical power. Because this is nothing but electron. So we can say that V equal to V is nothing but ED, the electric field, and length wherever the field acts. Then I is nothing but I is actually J A, yeah, because we know J equal to I by A is the current density. So it is seems to be E A D, or you can write also L J A. So this is actually E J V because it is the per unit volume. So you know that J equal to E J equal to sigma E, and this is volume. So the the electrical power, we can say that electrical power per unit volume is actually sigma E square. So this is the energy dissipation in the system. So think that this energy flow or power flow, whatever we said, that is equivalent to sigma E square. It is in the conductive system. But whenever we are talking about the different material, because we know that the material has two effective conductivity, that is actually conductivity due to the conduction, and another is the frequency domain conductivity. So think that if we talk about the energy, similarly here we can write it sigma effective electric field square. This is time dependent electric field, yeah? That is actually sigma square time dependent plus omega epsilon naught I time dependent field square. So how this energy actually thermal energy associated with the electric field and electric conductivities, and that is the conductive nature, conductive nature of the material. But whenever we are talking about this is associated with the conductive, yeah? Conductive nature, then this is associated with the dielectric nature. So think that the conductivity and dielectricity is actually the material two parts. So whenever we are talking about the microelectronic devices, that is ranging from low frequency to high frequency band, then there is another difficulty that actually we talk about the frequency dependent energy or conductivity of the materials. If we talk about the electrodynamics part, so we can write here that is the omega epsilon double naught, and this is the sigma. This is the due to conductivity, this is due to the permittivity or dielectric property. So if we talk about the frequency here, you see that the low frequency, the conductivity is high, any conductive materials, and it gradually decrease. And this is the trend of the frequency variation, frequency dependent conductivity of the conductor. This is conductor, yeah? because we are talking about the microelectronics that is comprises of capacitor and resistor. So resistor associated with the conductivity, or conductor capacitor associated with the dielectric properties of this. So think that at high frequency the dielectric itself is no more dielectric, it is conductive. So it moves like this. So this thing that the trend of this variation of conductivity with the frequency, that is very much impactful on the dissipation, or that effect we talking about the effective conductivity associated with the conductive properties of the materials and also the dielectric properties of the materials. Why we are talking about that? Because the microelectronic system, we can work it as a low frequency, high frequency, and also high power, because power MOSFET or power electronic devices transistor, high power, high frequency. So think that three aspects, there is a interrelationship of conductivity, the conductive dependence dissipation, and dielectric dependence dissipation. So such way we can plot that the variation of the conductivity from the high conductive low frequency, low conductive high frequency, and dielectric property also low dielectric dissipation at low frequency and high dielectric dissipation at high frequency. So think that now the devices are getting miniaturization. So in that situation, the high frequency band is now supporting. Now it is actually 10 gigahertz band, or very common now. Before it was maximum 3 gigahertz or something like that. So think that the frequency shift, that is the measuring the device, because the you know that the RC of the circuit actually related to tau, and whenever the frequency is getting higher, then tau definitely getting lower. So definitely you have to limit the resistance and conduct capacitance as well. And to do so, actually we need to miniaturize the device, and that device supported high frequency. Definitely dissipation of the dielectric is very much considerable. So think that the way that how we talking about the semiconductor materials dissipation in terms of conductivity, in terms of dielectric dissipation, and how it associated with the basic fundamental concept of the thermodynamic energy flow or heat flow. Because whenever we try to flow current to the material, definitely this dissipation happen, and that is nothing but actually I square R. And whenever we are talking about that, this is the power dissipation, and the energy, whenever we are talking about energy, this is power, yeah, but energy is actually I square RT. Whenever we apply the time, this is the energy. So here also the same thing, the time dependent, because here is the time variable of the electricity that eventually make it impact on the dissipation. Either it is conductive dissipation or dielectric dissipation, and that is interrelation with the fundamental thermodynamic energy infused right due to the heating effect. That's all from my side to the thank you. So,